So now let's do calculus. We have question 9, question 10, and question 11 for calculus. So let's start with question 9. It says determine f prime from the first principle given that f of x, and they give us the function. So we need to know what's f prime for the first principle. So f prime is going to be equals to the limit when h approaches 0 when f of h plus h minus f of x divided by h. This is what it means, right? So the first thing is we need to find the component. So I'm going to find f of x first, which is they gave us as being what? As being x squared plus, right? Then I need to find f of x plus h, which is wherever I see x, I'm going to substitute by this. So it's going to be, so I'm going to expand this and I'm going to distribute the 5 here. So let's do that. Then we done finding f of x and f of x plus h. Then just to make it simpler, what I do is I simplify the numerator outside. So I'm gonna find f of x plus h minus f of x, which is just the numerator, right? Then I'm gonna substitute together. So let's do that. Minus, then the f of x, I'm gonna put it in a bracket, which is gonna be, right? So here what I'm gonna do is I'm gonna distribute the negative here. So I'm gonna write the same thing the way it is, the first part the way it is. Then I'm gonna group like terms or cancel anyone that can cancel each other. What do we see? We see the fact that x squared and positive x squared and negative x squared are gonna cancel each other, right? Because they're gonna give me 0. Then I see the fact that 5 and positive 5x and negative 5x are gonna cancel each other because they're gonna give me 0, and negative 6 and positive 6 are gonna cancel each other. A tip that I need to tell you is that whenever, what needs to happen is that see f of x, when you subtract it with x plus h, this needs to cancel, this one needs to completely cancel, so it should not exist. Then you know the fact that you're doing something right. So now the simplified version is going to be what? After canceling everything, so this is what you left with. Then you always take out h as a common factor because we want to cancel it out with this denominator. So let's do that. Then you're going to take this and substitute it back into the formula. So let's do that. The h and h are going to cancel out. So you're going to be left with. Then when we substitute h, which is going to be 0, the limit drops. So you're going to have, so simplify this is going to be, then you're done with this question. So now let's answer 9.2.1. It says determine f prime if f of x is equals to the function. So they give us f of x. So now let's simplify this so that it's easy for us to use the differentiation rules. So the first thing is we're going to distribute what? We're going to distribute the 3x here and here. So let's do that, right? So we see the fact that here we have laws of exponents, right? So let's change this one, the square root, into it being an actual exponent. So let's do that. So since we have the laws of exponents, since the x's are the same base, we can basically add what? The exponents. So we're gonna have 1, because this is to the power 1, plus 0,5 minus 12x, because 1 over 2 is equals to 0,5. Then when you simplify this exponent, you're gonna get f prime is gonna be equals to, take this 3 over 2, take it to the front, so it's gonna be 3 multiplied by 3 over 2x. Then this one's gonna be subtracted, the 3 over 2 is gonna be subtracted by 1. Then take this has the same as being 1, so gonna say minus 12, take it to the front, the 1, so it's gonna be multiplied by 1. Then this is gonna be x, then it's gonna be 1 minus 1. Then when we simplify this, it's gonna be f prime is equals to what? It's gonna be 9 over 2, then x to the power 1 over 2 minus 12. Let's simplify this and make it into the square root, so it's going to be 9 over 2 root x minus 12. And we're done with this question. Then 9.2.2 says find dy over dx if y is equals to, then they give us a function. So dy and dx and f prime, same thing. We're finding the derivative, right? So but now is in terms of y, they gave us our function is being y, so we know that y is equals to, before we differentiate it, I want to simplify it, meaning getting rid of the what? Getting rid of the denominator so that it's easy to basically use the rules of differentiation. So let's do that. So first we're gonna take out x as being a common factor on top. Then what do we see? We see on top that we have a difference of 2 squares. So I'm gonna factorize using difference of 2 squares. And I have a video about the difference of 2 squares, so I'll link it up. So it's gonna be x minus 2 and x plus 2. So what do we see? We see the fact that this one, if we basically take out negative as a common factor, we can get exactly this. So let's do that. Remember, when we're taking a negative sign, this one's going to become what? Negative, and this one's going to become positive, right? Then after doing that is that I'm just going to rearrange the one in the denominator, the position, just the way they're sitting. So it's going to be like this. So x is going to come first and the 2 is going to come second. So do you see the fact that we have x minus 2? So they're going to cancel out. Then what we're going to be left, you're going to be left with this negative is going to make this whole thing negative. So it's the same as saying negative x plus 2. Then we're going to distribute the negative x inside. So we're going to have y as being what? As being negative x squared minus 2x, right? Then we're going to use the laws of differentiation to basically solve this. So now we can find dy over dx, which is going to be equals to, take the 2 to the front, it's going to be negative 2x, then it's going to be 2 minus 1, minus, take the 2, the 1 in front here, is going to be 2 multiplied by 1, x 1 minus 1. So our answer here is going to be negative 2x minus 2. Then you're done with this question. So now let's do question 10. It says the graph f of x is equals to x cubed plus bx plus cx plus d. Then they tell us that a is not equals to 0. Then they say it's sketched below. Then they tell us the fact that a is given as negative 1 and 0, which is the x-intercept, and c is given at what? As being 0 and 4, which is the turning point, and also is the and is both the local minimum and b is both the local minimum and the x-intercept. So another thing that they didn't tell us here is that c, right, is the what? Is the x is the turning point and also the what? The local maximum, right? And after that is that also is the y-intercept. So c is the y-intercept, right? And is the turning point and the local maximum, right? So yes. Then b, as they told us, the entire information is the turning point, is the x-intercept, and also is the what? Is the local minimum. So knowing all that, let's start with the first question, which is 10.1. It says write down the value of d, right? So what's d? D is this d here is the what? Is the y-intercept. So the y-intercept is what? It's going to be what? It's going to be 0 and d, right? And in our case, we have the y-intercept, which is c. We know the fact that c is what? Is 0 and 4. Therefore, d is going to be equals to 4. Then we're done with this question. So 10.2 says show that b is equals to negative 3 and c is equals to 0. So here what we need to do is we need to use simultaneous equation to actually solve for this question. So the first part is that since they already gave us as c, the coordinate of c, which is c, I said is the turning point, we can find the first derivative because the first derivative gives us the turning point, right? And we can basically substitute a, right? And when we substitute a is to basically create the first function. So let me do it so that you can see it. So we're gonna find the first equation, right? We're going to say f of x. We know that f of x is equals to what? Is equals to x cubed plus. Then here we're going to substitute a to find the first equation. So we're going to substitute a. So a is what? It's 0. It's negative 1 and 0. So y is what? Y is 0, which is f of x. Then x is negative 3. It's negative 1, sorry. But we know that d is what? D is 4. So we're going to substitute that. Then we're going to simplify it. So we're going to have, so negative 1 plus 4 is going to give me positive 3. So it's going to be b minus c and plus 3. Then I'm just going to take the c to the other side. So it's going to be positive when I take it to the other side. So therefore c is going to be equals to b plus 3. And I'm going to make this what? The first equation. Then now to find the second equation, I'm going to use the fact that c is the turning point. And knowing the fact that to find the turning point, we need to find the first derivative. So we're going to say f prime is equals to what? It's going to be equals to, it's going to be 3x squared here. Then it's going to be plus what? It's going to be plus 2bx. Then the last one is going to be c. Then the d is, since d is the constant, is going to get cancelled out. So this is the first derivative, right? Then what is the point that is linked with the first derivative? Is this one, is the point c. So after finding the first derivative, right, we know the fact that we need the turning point to basically find whatever c is here, right? But remember something. We remember the fact fact that here the point, this thing, f of x finding the turning point, we need to equate this side by 0, right? Then this is going to be equals to 3x plus 2bx plus c, right? So we already know 1 point from this thing when we factorize. We know the fact that from the turning point, the x value is that when x is equals to 0, right, is one of the factors here. So we're going to substitute this x equals to 0 coming from here, from the turning point, right? So let's do that. It's going to be 0 is equals to 3 open bracket 0 squared plus 2b 0 plus c, right? So this is going to be 0 and this is going to be 0. So therefore c is going to be equals to 0. So we already know that c is going to be equals to 0. So I'm going to substitute c here to get what? To get b. So we see the fact that we already found c. So let's substitute to get b. It's going to be 0 is equals to b plus 3. Take the 3 to the other side. It's going to be negative 3 is equals to b. So now we have solved for b, which is negative 3. So now 10.3, it says determine the equation of the tangent at f of x at x is equals to 5, right? So we need to find the gradient at a point when x is equals to 5. So let's do that first. So we know the fact that we have f of x, right? Our f of x is equals to what? Is equals to x cubed minus 3x plus 4, substituting my b and c, right? So first we need to find gradient at the point. So we need to find what? M, right? So to find m is equals to f prime, right? F prime at a specific point, which is in our case when x is equals to what? To 5. So let's find f prime first. So it's going to be f prime. So it's going to be what? You're going to take the 3 to the front. So it's going to be 3x. Then you're going to say 3 minus 1, which is going to give me 2. Then you're going to take the 1 in front here, which is going to be 3 multiplied by 1 is going to give me 3. Then x here is going to be what? 1 minus 1. Then the constant is going to cancel. So let's simplify this. Here I'm going to get 3x squared minus 3 at a point where x is equals to 1. So we're going to substitute this 5 here. So it's going to be what? We're going to get this as being, so which is going to be equals to 45. So therefore m is equals to f prime at 5, which is equals to 45, right? So now what we need to do is we have the gradient, right? So we know the fact that the equation of a straight line is y is equals to mx plus c, right? So we have m. So now we need a set of coordinates to substitute for y and x so we can get c. So to do that, we're going to take the 5 that they gave us to find f of 5, right? So we're going to substitute this to the original equation, which is going to be, this is to find the coordinate to substitute here. And when we substitute that, what we're going to get that f of 5 is equals to what? Is equals to 54. So the coordinate is going to be 5 and 54, right? So now let's substitute x and y here. So it's going to be x and y and m. So it's going to be 54 is equals to what? To 45, x which is 5 plus c. Take this to the other side. It's going to be 54 minus 45 and 5 is equals to c. Therefore my c is going to be equals to negative 171. So now making our equation, what is going to be y is equals to what? Our m is 45x minus 171. Then we're done with this question. So 10.4 says find the value of k, for which values of k will f of x equals to k have 2 equal positive roots and 1 negative root simultaneously. So what we need to do is we need to basically understand what is a root and how k affects the graph, right? So the first part that I'm going to do is I'm going to explain what's root. So roots are the y-intercept. It's where the graph cuts at the what? At the x-axis. So that are the roots. So we need to understand what's equal root first, right? Equal root is b. We see the fact that at b, right, is what is the turning point, right? So here, first of all, is that this point is a turning point, at the same time it's a root. So here there is only one root, right? So that are equal roots. Then unequal is going to be the fact that like it's going to cut at 2 different points. Then positive and negative roots. So a will be considered as being a negative root and b will be considered as being a positive root and an equal root because of it's a turning point there, right? So another part that we need to understand is that how k affects the graph. We have f of x, right, is equals to k. Let me write write the function of f of x, which is f of x is what here is going to be x cubed minus 3x plus 4, right, is equals to 4, is equals to k. So if I take the k to the other side, if I say this minus k is equals to 0. So what's this, right? K basically affects the graph going up and down, right? So k is the what? Is the vertical shift. That's what k is. So if I subtract by any value, like if right now, because I'm going to subtract by 2, negative 2, it's going to move the graph down. So k is moving the graph down because it's negative. I hope I'm making sense. So they want where if you shift the graph down, right, what's going to happen is we need 2 positive roots, 2 unequal roots, meaning we shouldn't have any turning point, and also we need what? We need 1 negative root simultaneously. So here on the graph, let me create what? Let me create from 4 going down. So let me say this is 3, 2, 1, and this is 0. So let me just write it properly. This is 1, 2, and this is 3, right? And this is 0. Okay? So if I had to shift the graph, let's say now k is what? K is going to be equals to 1. So I'm going to move it down. So if I move it down, this is going to be what? It's going to be x cubed minus 3x. This is going to be 4 minus 1 because this k is 1. So it's going to give me what? Plus 3. So now this part is going to move here. So I'm going to do it in green. So this one for this one for k equals to 1 is going to be here. I just want you guys to see it visually. It's going to be like this. The graph is going to just move down like this, and everything is going to move 1 unit down, right? So even this point is going to move down by 1 unit. So it's going to go like this. What do we see? We see that the green graph, right, this graph has 2 positive roots, right, and also 1 negative root, right? So if now I say k, let me do it in red, k is equals to 2, right? It's going to move, it's going to move 2 units down, right? K minus 2 is going to give me what? It's going to give me x cubed minus 3x, right? Then 4 minus 2 is going to give me what? It's going to give me positive 2. So it's going to be here. So it's going to move 2 units down like this, and here it's going to move another 2 units down. So it's going to be like this, right? So we see the fact that we have another 2 unequal positive roots and 1 negative root. So let's do for what? For 1, right? So if now I say k, right, is equals to what? Let me do it in another color. Now let me say k is equals to what? Is equals to, I said 1, 2, 3. Right? So it's going to be what? It's going to be 4 minus 3. It's going to give me what? It's going to give me 1. So it's going to be x cubed minus 3x minus 1. Because of 4 minus 3 is going to give me 1. So it's going to be here, right? It's going to go down again like that and like this. I gain 2 positive unequal roots, and we're going to have 1 negative root. So if now I say k, right, is equals to what? K is equals to 4. Let me do it in another color so that you guys can see. So let me take green. If I say yellow, let me take yellow. 4 minus 4 is going to give me what? It's going to be x cubed minus 3x, and 4 minus 4 is going to give me 0. So it's going to be like this. So the graph is going to cut here. It's going to go like this. So what do we see? We see the fact that it's going to have equal roots here because of my turning point is going to be what? It's going to be here, right? So my turning point is going to be here, and it's only going to have what? It's going to have only 1 positive root. So looking at this multiple graphs, right? So we see the fact that when k is equals to 4, when k is equals to 0 here, right? So when k is equals to 0, if I substitute 0 here, right? Let me make it another color. Let me make it pink. If I had to say k is equals to 0, right? It's going to be what? It's going to be x cubed minus 3x plus 4. This is going to be 0. So it's going to be the original graph. This is going to be just the original graph, right? The one that we just have when k is equals to 0. But what do we see? When k is equals to 0 is that we're going to have what? We're going to have equal roots here, which is not what we want. And also we're going to have 1 negative root. So that's what we want. But that's not what we want. What we want is 2, right? 2 positive unequal roots and 1 negative root. We see the fact that green has that. See, it's 2 unequal positive roots and 1 negative root. We see that red that has that too. It's 2 unequal roots, right? And 1 negative root. And we see the fact that what? We see the fact that blue has that too. Is that we have 2 unequal roots and 1 negative root. Knowing that, therefore, k needs to be between what? Needs to be between 3 between 3 and 1. K cannot be 0 because of at 0 it curves, the turning point is there, so there's an equal root here. So our K value is going to be what? Equals to, right? It's going to be equals at 3 till what? Till 1. So that will be your answer here, is that K needs to be between this, or this is the same thing as saying this from 0 till 4. The reason why is this is the same thing. This is not, it says the fact that 0 and 4 are not included. Here we say 3 and 1 are included. So those two are exactly the same thing. Then the last question says, determine the coordinates of the local minimum of g of x if g of x is equals to f of x inside is negative x plus 3. So we know the fact that g of x is equals to f of negative x plus 3. So we need to find f of negative x, right? So that's going to give me what? It's going to be negative x cubed minus 3x squared plus 4, right? From the original f of x, where now inside x I'm gonna add x, I'm gonna put negative x. So that's what I did. Then when I simplify, this is gonna be negative x cubed, and this is gonna be minus 3x squared, and this is gonna be plus 4, right? Then they tell me, so I'm gonna take this and I'm gonna substitute it here. So it's gonna be g of x is equals to what? Is equals to this one, which is negative x cubed minus 3x plus 4, what? Plus 4 plus 3. So this is gonna be 7. So g of x is equals to what? To negative x cubed minus 3x plus 7. So now I need to find the first derivative, because the first derivative gives us the turning point, which the turning points are your local minimum or local maximum. So let's do that. So it's going to be g prime of x is equals to what? It's equals to negative 3x, right, squared minus 6x. Then this one is going to cancel and being 0. So after doing that, we know the fact that this side is going to be equated by 0. Then we're going to factorize this, so it's going to be x, then we're going to have negative 3x, then minus 6, equate both sides by 0, equate both parts by 0. So let's do that. It's going to give me x is equals to 0, or negative 3x minus 6 is equals to 0. Take the 6 to the other side, it's going to be negative 3x is equals to 6, divide both sides by 3, is going to be x is equals to negative 2, right? So now what we're going to do is we're going to substitute the 0 and negative 2 to the original to check. So we're gonna have g of 0, which is gonna give me 7 here. Then we're gonna find g of 2. So here the coordinates is gonna be what? It's gonna be 0 and 7. And here for g of 2 is gonna be negative 2. So you're gonna get it to be 3. So here the coordinates is gonna be negative 2 and 3, right? So first we need to understand how the graph basically changes, right? So how negative x affects the graph, right? So from the original graph, right, f of x, if x is negative, what's going to happen is that this turning point is going to turn and come here. So instead of here being what? It's 2 and 0, right? So here it's going to be what? It's going to be negative 2 and 0. So the b prime here is going to be this side. So the graph is going to be what? It's going to be like this, going like this. And here nothing changes. So it's just going to be like this. So this is how the graph is going to be like when it's what? When it's x negative. Then the plus 3, meaning the fact that the graph is just going to move upwards by 3 units. So let's do that. It's going to go up by 3 units. So let's say this is 1, 2, 3. So it's going to be somewhere here. So it's going to be like this. So knowing the fact that the blue one is what? Is g of x, right? Because of it's affected by negative x and it goes 3 units up. We know the fact that our first turning point is here, which is going to be 0 and 7. And the other one is going to be here, which is negative 2 from the calculations and 3, right? So therefore, even without the calculations, you see the fact that our answer is what? Is negative 2 and 3. But with the calculation, it still arrives to the same answer. So here, the local minimum for this question is what? Is negative 2 and 3. Then you're done with this question. So now moving to question 11, it says use the information below to draw the graph of the function defined by f of x is equals to ax squared. ax cubed plus bx squared plus c x plus d. Indicate the intercepts with the x's as well as the coordinate of the turning point. So the information that they give us is that f, right? So f of 0 is equals to 3, right? So which one do we know the fact that when it's when x is equals to 0 and we get a value, it's what? This is the y-intercept. This is the y-intercept. Reason why is that we let x equals to 0. So the coordinate here is going to be what? It's going to be 0 and 3. The 0, the x here, where there is x, for f of x, they substituted 0. So that is why this is the what? This is the y-intercept. Then we have another one, which is, so this one I'm going to say y-intercept, and I'm going to write the coordinate as being 0 and 3. Then the second set of information is that f of negative 3 is equals to 0. Which one do we know the fact that it has 0 as being y is what? Is the x-intercepts, right? Because we let y equals to 0, and this represents y, and here represents x, so the coordinate is going to be negative 3 and 0. So this is going to be what? The coordinate is going to be what? It's going to be negative 3 and 0. That are your x-intercept and your y-intercept. Then what sets of information do we know? We know the fact that finding the first derivative, right, when x is equals to 0, what do we find? We find in the x-coordinate of the turning point. X-coordinate of the turning point, right? That's what we know. So here they tell us the fact that f prime at negative 2 and it is equals to f prime at 1 is equals to 0. So this is the first derivative when we equate it to 0, and we find the a negative 2 and 1. So they found that the coordinate here is negative 2 and 1. Right? Then the second set tells us the fact that f at negative 2, which is the x value of the turning point, so f at negative 2 is equals to 5. So here the first turning point is what? Is negative 2 and 5, and here the second set of coordinate at 1 is equals to 1, which is the second coordinate for the turning point. So this bottom part is the turning point, and we have what? Negative 2 and 5 and 1, and so now we can draw the graph. So let's do that. So now having the Cartesian plane, let's first put the x and y intercepts. We have the first one, which is 0 and 3. So 0 and 3 represents what? The y-intercept. So it's going to be here in pink. And the other one is negative 3 and 0, which is going to be the x-intercept. So it's going to be here, right? So now in another color, let me put the turning points. The first one is negative 2 and 5. So negative 2 is here and 5 is here. And the other one is 1 and 1, which is here and here. Then let's connect everything together. So I'm going to start here by the turning point, going like this. So it's like this. Then we know the fact that the blue part is the turning point, so it needs to curve, and that's basically f of x. So now going to 11.2.1 says determine the values of x for which x multiplied by f of x is less than 0. So what does that mean? It means the fact that we have f multiplied by f of x, right? It needs to be less than 0, meaning that it needs to be negative. What does it mean? It means the fact that when the function x, right, multiply with the function f of x, it needs to give me negative. So meaning this one, it's either x needs to be what? Needs to be positive, and therefore f of x needs to be negative. Then when you multiply these two together, you're going to get a negative, right? Or it's vice versa. This one needs to be negative and this one needs to be positive. And when you multiply those two together, you're going to get what? You're going to get a negative, right? So this is the only two conditions that we need to follow to actually do that. So to actually see that, what we need to do is we need to draw x, right? So this is x is the same as saying y is equals to x. So let me draw that line. It goes through here like this. Just gonna sketch it roughly so you can draw it in your question paper in pencil so that you can see it. So we want when there's two graph, right, we want it's either one needs to be positive in the positive y-axis. We're focusing on the y-axis, right? One needs to be on the y-axis in the positive y-axis and one needs to be in the negative y-axis, right? So we see from where, before we do that, we need to find the intercept, where the graph intercepts, right? The x-intercept to be specific. So I'm going to do it in pink. This one is the first one at x is equals to negative 3 is the first one. And the other one for the blue one is what? It's x is equals to 0, right? This is the other one. So after finding that, we need to check where the two graph exist, where the other one is going to be negative and the other one is going to be positive. So between negative infinity, right, till 3, what do we see? We see the fact that both graphs here, both graphs are what? A negative. And a negative gives a positive. So we can't use that. But from 3 till 0, what do we see? We see the fact that f of x is what? It's going to be what? It's going to be on the positive side. And x is going to be what? Y is equals to x is going to be what? On the negative side. So this range basically works for our condition, right? But from where? From 0 till positive infinity, we see that what? Both graphs are on the positive side. So to answer our question now, our x for the x values, right? Our answer is going to be what? It's going to be between -3 and 0. And this will be your answer for what? For 11.2.1. Then the last question says 11.2.2 says if g of x is equals to negative f of x, write down the coordinates of the local minimum. So what is negative f of x? It basically flips the graph, right? So the minimum becomes the maximum and the maximum becomes the minimum. So this one is going to basically go on to this one is going to basically go down. It's going to flip it. So here the coordinates are what? We know that the coordinates are going to be -2 and 5, right? And here the coordinates are going to be what? Are going to be 1 and 1. So what happens when f of x is negative? Right? So for g of x is that the local minimum is going to become a local maximum is going to become a local minimum, and the local minimum is going to become a local maximum. So this one is going to change, this one, right? It's going to change and it's going to flip to the other side. So since from here to here it's 5, right? It's going to flip to the other side to being 5 here. So if I had to extend this down, if I extend this and 5 is here, this point is going to be basically here. So this is going to be the new local, what? Local minimum. Then this 1 is going to flip, right? Since it's +1, right? It's going to be -1. So it's going to be here, but now it's going to be what? A local maximum. So the new graph is going to be like this when a negative f of x. So here the coordinate is going to be -2, same coordinate, but the 5 is going to change from being a positive to being a negative. So for 11.2.2 is going to be what? My answer is going to be -2 and -5.